So what do you guys think Ethereum is? Just yell out some blanket statements. Thank you so much, everyone, for coming and joining me today. I think it's like 2 o'clock here at this point. I'm kind of dazed. For those of you guys that know, I've been sick for the past couple of days, so I'm not really like fully in tune. And typically, I'm not also in tune with time cycles because I work pretty obnoxious hours. So I'm going to start off by giving you guys a background about myself, very quick background, a background about how I got introduced to this space, and then we're going to go into what I like to call the inception of the blockchain or the inception of Ethereum, and then we'll go straight through this PowerPoint presentation, which is a more technical, under the hood look at what Ethereum is. So before I get started, you got some housekeeping rules. Do we turn off phones?
No, they have phones.
Oh, everyone has, okay, perfect, good. Number 2, I speak really fast. And maybe you've already picked up, I'm not from here, so my accent's kind of strange. So I apologize for that already. If I need to repeat something, let me know, I will repeat it. Apart from that, we'll have a fun old time for today. Who is familiar with Ethereum? 1, 2, 3, 4. Who has developed something on Ethereum? You. Fantastic. Have you run it on LiveNet? No, just testnet? Okay. And did you do that just at home by yourself or at school? At home. Who has heard about Bitcoin? Who has played around with a cryptocurrency wallet? One person. Who is a first-year student? Wow, lots of first-year students. All computer science? Who's a second-year student? Shout out to the second years, you guys are getting through school. Who's a third-year student? And who's fourth year? Fourth year. And there's only 4 years, right? Still? Good. You're third year. And all of you attend this university, is that correct? Fantastic, fantastic. So that gives me a good gauging on the room, because I think that will give us a lot of color as we go through this introduction. So background on myself, I hate when speakers just keep talking about themselves, so I'm going to keep this really quick. My name is Shorupan. I was born in Toronto, Canada, which is like a cold country, very far away. My parents were actually born not too far from here, and they migrated there. And so I was born there. In 2017, I started Canada's first cryptocurrency bank. I know that sounds pretty crazy from here, but there it made a lot of sense. There was a lot of people who wanted to go between Canadian dollars and Bitcoin, and so we provided an institution for them to do that. That became called Nvest Bank. You can go find it at investbank.com. The really novel idea that we had was that everyone at the time was building digital wallets. Typically, that's what you do because cryptocurrency is a digital currency. So I thought I was really smart, and I wanted to build a physical branch for a digital currency. And so I built the world's first physical cryptocurrency bank in Toronto and London, and that kind of became very popular. So I will show you guys a quick video of what that looks like, just because there's nothing like this in the whole world. And it seems to be enticing to people. Well, it has a lot less dramatic impact without the sound, but as you can see, this is like an ICICI branch or a Barclays branch, and we have these across Canada. And when I started it, it was a really novel idea because no one thought that you needed something like this for crypto, but it became quite useful actually. Because it's still the foundation of a lot of the business that we do in both Canada and the United Kingdom. And that's my co-founder. It's a good friend of mine. I think I'm in one of these pictures somewhere, looking really interesting. And that really set us on a path to where we are today. I wish I could spend more time just talking about that, but again, I don't want to bore you. Beautiful. Along with that, in 2018, as the introduction leader said, we launched the Nvest Group, which became like a private equity fund that invested in cryptocurrency companies. So we took our banking infrastructure and really wanted to invest in as many companies as possible in the crypto space across the world. And so at this point, we have like 29 companies in our portfolio. And I came to India in August of 2018 to Jaynagar, which is where I still reside. And I built a research and development facility, which there's lots of videos on YouTube. You can go look at it later. It's called Nvest Campus. That's actually where all of these guys work. And that's almost a 100-person R&D facility for the leading software development done in the blockchain space for all of the companies across the world that we've invested into. We have a production studio, we have a training academy, we have software house. And that's really becoming a very fun part of our business. And that's where I spend most of my time. That's where I'm coming from right now. And so what we realized as we started to scale out our operations is that there is not enough people graduating with knowledge about the blockchain or how to develop on important protocols such as Ethereum. And so this is not just a trend that happens here in India, but it's a trend that happens globally. Typically, universities adjust slowly to new technologies, and that affects the career paths of many of their students, because if you are leaving school unequipped to face cutting edge technologies, then you're probably going to take a job working on a legacy technology that's going to be out of use very soon, like .NET or something along those lines. And what we wanted to do is formulate an academy, not just here, actually we started in Toronto, that would work with universities to provide certifications in blockchain technology for engineers that want to develop that cadence. And so we call that NvestLabs. You can go to NvestLabs.com and check it out. That's a training academy that we've developed online and offline for the education of blockchain. And we've partnered with multiple universities in Canada, the United Kingdom, the United States, and now in India to propagate these courses. And our main course is a certified Ethereum developer certification, which is comprised of 3 different courses: an introduction to JavaScript, a certified Ethereum developer level 1, and a certified Ethereum developer level 2. That's almost a 112-hour course. It's very intense. It's taught by 3 different instructors. You have like electives, super intense stuff. And our first one, I think, is launching for India at the beginning of November. Today, I'm doing a workshop for this university, as I'm doing across the country, just to introduce the idea of Ethereum. Because so many of you have never heard about it or just heard about it. And to me, I'm actually not that different in age from most of you guys. I'm assuming most of you are either like, 19 to 22, like that age group, 18 to 22. I'm not going to reveal my age, but like we'll talk about it after, I guess. To not understand Ethereum today would be like not understanding HTTPS in 98, 99. It would be like not understanding how modern search indexing works in 2003, 2004. It would be so uncompetitive to the future of this technology apparatus that it's scary. And so today, what I want you guys to leave with is what makes this technology special. As developers, it's very easy to get caught in the low-level languages, right? You're learning about C++, you're learning about C++, and you're thinking, how does this communicate with the metal? How am I gonna, program this certain application stack? And we miss out on what it is that we're trying to accomplish. And I think the blockchain, and Ethereum specifically, forces developers like you guys to think about what it is that you're trying to accomplish with your code. I think It's one of the most marvelous inventions of the last 200 years, what the blockchain has done, and it empowers you, not just as future developers for other companies or institutions, but as people that now can take your code and deliver it on a decentralized network that is virtually unstoppable. We'll talk about all of that. But really, that's my objective today, is to make sure you guys leave today and Google the shit out of everything that I told you. If I accomplish that much, then it's mission accomplished. At any given point, if you have questions, please save them until the end. I will address all of them. If I can't address them because of time or something, email me. I will make sure to address all of them. Call me, whatever it is, we'll make sure we get through all of it. I just want to make sure that we deliver the significance of what it is that we're here to talk about, because this is very important stuff. So without further ado, let's rock and roll. Let's get straight into what is Ethereum. So, what's my time? What's my time right now? 2:09. Okay, cool. I like to spend, usually when I do this, it's been a long time since I did one of these. It's been like at least 2 months. But usually when I do this, I try to ask the audience, the developers, why Ethereum? Before we talk about what is Ethereum, because that's easy, that's well documented. The question is, why did it come about? So, what do you guys think Ethereum is? Just yell out some blanket statements. I will force participation if I need to. So, anything, there's no such thing as a dumb answer. Cryptocurrency. That is true. It is indeed a cryptocurrency. Anything else? It is decentralized. That is also a fact. Anything else? It begins with the E. It ends with an M. Some amount of letters long. It's on the screen, I think. Oh, there it is. Yes. Okay, so that's as deep as we know as it pertains to that. What do you think a cryptocurrency is? How about we start with that then? What is a cryptocurrency? Sorry, who said that? Online currency which is encrypted. Anyone else? That's a good answer. It creates anonymity. Okay, it creates anonymity. Interesting. Anything else? Did we promise cryptocurrency for everyone that came today? Did you make that promise? Some of them were promised cryptocurrency. Cool. Whoever was promised cryptocurrency, come see me. I will give you tons of crypto. Don't worry. And you can use it however you wish. Anything else? All right, cool. I think then we got to take a step back, because maybe first year, there's a lot of first year, second year students, so now I'm starting to remember how I was in first and second year. I was kind of more... Yes, if you answer more questions, Nishant will keep track, and he will give you more cryptocurrency out of his paycheck. No, I'm joking. No, it'll be mine. Sorry, Nishant is a wonderful, he's interning at my company, so he's been absolutely phenomenal helping and working on a really cool project, actually. Okay, let's take a step back, shall we? What is a cryptocurrency? I think it's going to be hard to move on before we define that. Okay, a cryptocurrency, by the two answers I got here, is an encrypted digital currency and something that creates anonymity. So what was the first cryptocurrency? It was one before Ethereum. Bitcoin. Bitcoin was created, do you know when? Say it again? 2007, 2008. Yes, that is absolutely correct. By whom? Which we don't know who that is. We're still trying to find that guy out, or her, or group, or alien, or whatever it so may be. And what is the use of cryptocurrency? What was his objective? What was his vision? Did someone say something? Eliminate validation? Okay, interesting. Expand on that. What do you mean by eliminate validation?
If you want to be decentralized as well as you didn't
He wants to or didn't want to? He didn't want to, okay? Okay, cool. So, I will give you a 2-minute, or maybe longer than that, lesson on kind of why Satoshi Nakamoto created cryptocurrency. If you're interested in more of the historical implications of that, I just wrote a book on Bitcoin that I've been meaning to release for a couple months, but seem to not been able to get around to it. It's called A Decade of Decentralization. It'll be on Amazon soon. That breaks down all of the technological advancements that led up to Bitcoin itself. But let's make it very simple. You ever taken an auto? Like you ever taken an auto rickshaw? Okay, cool. Now the auto rickshaw guys are using like Google Pay and stuff, right? But once upon a time, they didn't have Google Pay, so you'd only been able to pay them cash, right? So don't you think it would be very weird? Like when you used an auto, doesn't matter if you're a girl, boy, fat, skinny, poor, white, you just got out of the auto and you paid him the cash and he took it. Okay, that's how the world ran for the better half of 700, 800 years on these stores of value that were made of paper or were made of some representation of paper. Now the good thing about paper money is that paper money doesn't involve the validation of a central party upon transaction. So if I take out 100 rupees and I give it to you, nobody needed to know that I gave it to her. Does that make sense? Now there had to be some government to print it, so the point of issuance is still centralized. If you look at the database architecture of a fiat currency, the point of issuance is still centralized, but the point of transaction is highly decentralized. Does that make sense? Now come 2000 and the internet starts to emerge, and you can't do that on the internet. You can't just take out 100 rupees and give someone 100 rupees, because fundamentally bits, which is what you program into a computer, are abundant resources. Rupees are not abundant resources. That's what makes them valuable. Does that make sense? If you have an email, you can send that to 1 million people. It's not going to cost you anything. You can't send that same rupee to 1 million people. That will cost you a lot of money. And so how the world solved that problem was by creating highly centralized points of transaction. Visa, MasterCard, Facebook, PayPal, Google Pay. I mean, these are newer ones, but then all of these became central points of transaction. So if I wanted to give her the same 100 rupees on the internet, Google or Facebook or Visa or MasterCard or Rupa, PhonePe, someone has to validate. They have to watch that. Does that make sense? So the real computer science question that Satoshi Nakamoto solved is, how do you subvert the double spend problem when it comes to the distribution of bits? In other words, how do you make bits scarce? Now that's a crazy problem to solve, right? I call Satoshi Nakamoto our Martin Luther King Sr. For those of you guys that know, Martin Luther King led the Protestant Revolution, was a very influential person. He is that influential. Bitcoin is so important. Trust me, no one knows this yet. Don't worry, it will become. It is such a remarkable invention, not because of the money element. The money element doesn't really matter about cryptocurrency. It's what he proved in achieving mass consensus in the world of bits. So how did he do it? He created a consensus algorithm using something called SHA-256, which is a very famous cryptographic hash function. And he basically said, we are going to let anybody, any computers to be specific, validate anyone else's transaction. We are going to create a decentralized network that's decentralized at the point of issuance, which means there's no government issuing the currency. It's also decentralized at the point of transaction, which means there's no central party validating this transaction. How is the validation now going to occur? It's going to occur through a set of decentralized nodes, millions of them. Anybody with a computer can be a node. Anyone with a phone theoretically could be a node. And these nodes are performing something called a consensus algorithm. And this consensus algorithm is a highly heavy computational piece of, like it's a piece of math that keeps spinning. that you might call cryptocurrency mining is basically this term that proves that the person who is validating this transaction is telling the truth. Now, how that actually works is fascinating, and that's maybe a point that we can do on an Introduction to Bitcoin course. But you start to get the idea. Satoshi Nakamoto, with the invention of Bitcoin, changed the way we validate transactions for money. Does that make sense? Why that might be actually important is unprecedented. For the first time, you can do peer-to-peer transactions. You can choose, like, I don't want to make this too socioeconomic, because I know we want to keep it to Ethereum, we want to keep it to like kind of the programming stuff, but let me just give you context. For the first time in 2008, actually Satoshi Nakamoto created it specifically in 2008, or he released it in 2008 because it was a response to the world's financial crisis. You guys were very young, but in 2007, 2008, the world experienced one of the worst financial crises since the Great Depression, led by a housing bubble in the United States. And so the world's financial system had the least amount of trust in almost 100 years. And what Bitcoin aspired to do was actually issue a currency and a protocol that did not require any trust. It did not require you to trust me or the other person you're sending the money to, or a government or an entity. It would allow you to trust in the cryptography which underpinned each hash function. And now, if you think about that, the reason Bitcoin makes so many people uncomfortable, so many governments uncomfortable, so many government leaders, which I speak to on a daily basis, it's almost like my job for 1 or 2 hours to speak to regulators in any country. And the reason it makes them uncomfortable is because it fundamentally questions the way that decisions are now made. Obviously in money, because that's what it first tackled. But number two, if you no longer need trust to do a transaction, you can build as a developer unlimited applications on top of that same protocol and empower any type of transaction. And that unleashed what we would now know as the cryptocurrency revolution. It's very new. I'm not surprised you guys don't know much about it, or it's very new. Trust me, it's very new. Nowhere in the world do they understand it quite clearly, but it is pivotal that you wrap your head around it. Because whether you're interested in IoT or machine learning, distributed artificial intelligence, applications in healthcare, biotech, does not matter. Ethereum and the principles upon which Ethereum are formatted will underpin every single one of those industries without a question. I'll give you those use cases after. All right, this is what you're going to talk about today. Ethereum basics under the hood of Ethereum and decentralized apps. Let's see where we go from here. Oh, does anyone know this character? Vitalik. Me and Vitalik grew up like 2 hours away from each other. That's another crazy story. I was born in Toronto. He was probably born in Eastern Toronto and then went to Waterloo, which is also the school that I aspire to go to, which is just a crazy coincidence. Vitalik is a very interesting person. He's almost as interesting as Satoshi Nakamoto. I've actually had the chance of meeting and talking to him, and I don't know how old he is today. How is he, 23, 24, something like that? Some crazy, he's very young too. But essentially, this is how Ethereum was founded. Vitalik believed that Bitcoin was such a marvelous invention. He was writing, I think he might have created Bitcoin magazine. He was definitely writing for Bitcoin magazine in 2013. This is how early he was involved. They used to pay him to write articles for Bitcoin magazine, and his payment would be like a Bitcoin for like one article. Like that's how 2013, that's how where the world was. Obviously, I don't think he kept that coins, who knows, but I don't think he's kept it. Anyway, he became very astute. He became a prodigy. He was a part of the Thiel Fellowship. He fell in love with the idea of distributed ledgers, open blockchains. And he went to the Bitcoin organization. He went to the Bitcoin community. And you know what he said? Guys, we need to develop a general purpose programming language for Bitcoin. Bitcoin is not general purpose. It is not Turing complete. Bitcoin has a very specific purpose, has very specific application sets, has extraordinarily stringent security measures, because it's only meant for one thing: secure, immutable transactions. They're slow, they're expensive, but they are the most secure and immutable transactions ever created. For the last 10 years, 11 years almost, the heartbeat of Bitcoin has been going off without a single downtime, without a single hack. Every bank, major bank in the world, has experienced security vulnerabilities. Every federal currency has experienced vulnerabilities. That doesn't mean Bitcoin hasn't fluctuated. It means the underlying protocol, the system, the computer system it is running on has gone off flawlessly. To do that without a company, without a government, without a central party, without organization is remarkable. Anyway, Vitalik, being young and ambitious, said, you guys have to create a general purpose programming language so that we can build scripting applications, run scripting applications. We can take Bitcoin and look at what it did for transactions. We can do it for everything. That was his idea. What I don't talk about in this presentation is kind of old, so I apologize. I will deviate off of it a lot. Vitalik wanted to create a vending machine for the blockchain. What I mean by that is Bitcoin is not a vending machine, if you conceptualize that. Bitcoin is like an auntie who can only serve one thing. Like you go and she'll give you like some masala and she'll give you that every day. Vitalik said we should be able to script the blockchain, overlay it, write whatever applications we want, and deploy it ourselves. And that type of vending machine blockchain just kept running through his head. And you know what the Bitcoin community said? Yeah, right. There's no chance we're changing Bitcoin. Now we know it as Bitcoin Core. At that time, they still called it Bitcoin. There's no chance. And what do you know? You're some 22-year-old kid. And Vitalik said, you know what? I'm just going to create my own. And that was Ethereum. And Ethereum was definitely launched in 2013. And this is really the timeline of Ether. The idea is like 2013 October. He did the world's first crowd ICO in 2014. The Ethereum Foundation, which is the non-for-profit that's set up in Switzerland to kind of monitor the Ethereum network and make sure that the developers are all working toward common goals, were set up in September 2014. The first release of Ethereum, or what we would now know as mainnet, was 2015, and then the official release that went into production was about 2016. So it's actually a pretty reasonable development timeline for such a big project. What I don't think Vitalik understood at the time is how many people were thinking like him. Computer scientists, leading cryptographers into this open source project was incredible. And over this 3 years, they made history. I mean, it's just unbelievable what they accomplished. To build out what now is Ethereum is just truly remarkable. So, what are the key concepts that we need to understand? Cryptography, I think everyone here has more or less an understanding of how cryptography functions, definitely in the context of a blockchain. We have what a blockchain is. That's pretty simple stuff. I'll go over that again. And smart contracts. Smart contracts are the main result of what Ethereum has created using this general purpose programming language. So, these are very fundamental aspects of Ethereum and some other blockchains. You have hash functions. Hash functions more or less are the foundation of any blockchain because they are what allow any type of decentralized validation in something that we would call proof of work. Proof of work is that same type of consensus algorithm which validates that I did some work. It's a very funny idea if you look at it from hindsight. Basically, it proves that I did something without knowing what I did, but you would know if it was right. that in itself is also a remarkable accomplishment of computer science, but logically speaking, it's a very funny idea. But it is the underpinning of all Bitcoin, and to this day, Ethereum. You have symmetric functions, asymmetric functions. Oh, I have asymmetric functions twice on this sheet. Forgive me. So, cryptography, let's go into hash functions. So, Bitcoin uses the most popular hash function known to man, which most banks, governments, and almost any online infrastructure uses, which is SHA-256, which is a very complicated hash function, which has umpteen amounts of results when you try to hash it, and is virtually impossible to break, which is why everyone uses it. And it's quite well tested, quite well documented, and like I said, has so much literature that supports its validity that, of course, Bitcoin, which is espousing to be the most secure cryptocurrency, is trying to use it. Ethereum, on the other hand, tried to use this KEKAK 256, which is similar to SHA-3, but has some slight deviations, which you guys don't need to understand for the purpose of this course, but already what it should show you is that Ethereum from day one, from architecture planning, was not trying to be like Bitcoin. And those architecture decisions would have huge implications later on as Ethereum started to mature. It actually won a contest in 2007 and is used today for all Ethereum mining. If you guys ever run an Ethereum miner, you'll become very familiar with it. And is derived differently than standard block cipher-based hashes or previous SHA functions. It has really different derivation functions, and that in and of itself allows Ethereum to validate certain actions in a way that Bitcoin can't, which we'll come back to. Digital signatures. Does anyone know anything about digital signatures outside of the blockchain? Because it's also used in most HTTP, most common web infra. So if you're like looking at network architecture or any type of cybersecurity, you'll learn about digital signatures, even if you don't care about the blockchain. So realistically, they're the same use case cryptographic method, ECDSA, as Bitcoin. So Ethereum didn't want to deviate too much away from the creation of digital signatures that Bitcoin really perfected. And the underpinning of all Bitcoin's success is the ability to issue these public-private keys, which is rooted deeply in this incredible cryptographic method. So again, everything comes back to how well can he validate or prove that I am following every subset of the original protocol. That is what a blockchain allows. A blockchain is a way for any of you to prove that I'm playing by the rules. Whether it's Ethereum has its own set of rules, let's say it's cricket, Bitcoin has its own set of rules, it's like basketball, Neo has its own set, Litecoin has its own set, and the beauty of the way that the cryptographic schemes are written is it allows any of you to validate my participation. And then the economic incentives, really the only cryptocurrency element of a blockchain is the incentive management. And once you can have a mechanism of validation, how do you incentivize good behavior? That is what Satoshi Nakamoto created Bitcoin, the currency, for. That is what then Ether, gas, these are all derivations of that. Signed messages can be verified using the signer's public key. Hashes are signed in Ethereum, not the data itself. So really the big key here is that the signing of the public key validates my participation in this transaction, not anything else, not a third party, not multiple third parties overlooking the transaction, but my signature, my digital signature that I imprinted on the public key of this transaction, which later then would go on the Ethereum blockchain. So the fundamental idea of a blockchain is that it's a distributed database. This is actually a very honest representation of what's going on. Blockchain purists, and I'm definitely to some degree a blockchain purist, have the issue, or I think the fault, of always saying a blockchain is the best or a blockchain is always necessary. In fact, that is not true. Blockchains as a database architecture is not always necessary. Actually, for a lot of things, they suck, as it shows here. the advantages of a blockchain is that it's highly secure. That is incorrect. It is not highly secure. It is virtually impenetrable if done correctly. If done correctly. It is transparent, meaning anybody can download the node, anybody can check every single thing on it. And it's immutable. In the way that immutability is validated is also remarkable. The disadvantages, scaling and performance. In other words, it's slow and expensive. So why would anyone ever want to use a database that's slow and expensive? Only if the information that they plan on putting on it, paramount is security. Paramount is immutability. Now, just to do a thought experiment, what information would qualify into that category? It's not everything. For example, my Facebook likes, I don't really care if they're that secure. Like, Facebook doesn't need to put all of its data on the blockchain. I think that would be, too expensive, too costly, and too slow for my liking. So that's not really that important information. But there are some pieces of information that I own, pieces of data, that immutability for sure is paramount. What do you guys think that would be? Well, Satoshi Nakamoto thought it was money, and that's the first thing he put on it. He thought that money and the creation and distribution of money should be transparent, immutable, and highly secure. Now, we can argue about whether that's true or not, but he believed that. Apart from money, what else do you think should take the approach of a blockchain for its database architecture? Personal data. Is that what you said? What type of personal data? Say that again? Photos, recordings. Interesting. Okay. So that actually opens up a really interesting debate about who actually even owns the data that's personal or not personal. That's a huge conversation. And there are many companies and people that would debate both sides of that. I think one that's really interesting that I think the blockchain is going to have huge implications on is land ownership. So I don't know if you guys are familiar. Who here is from not the city? Who's here from the more rural areas of India? Born not in the city? Nobody. Everyone here is from the city. Okay, cool. If you look at the mass aggregate land in India, which is obviously a huge amount of land, colossal. Right? It doesn't matter if it's the United States, doesn't matter if it's India, doesn't matter if it's Russia, any country with these massive land masses. The land registries are fragmented, hyper-fragmented, meaning if you go far enough out of Bangalore, I'm sure they still keep their land registries on paper. I can take that bet. But then the question is, who has the authority to change that? Who has the authority to validate when land has been transferred? Now, I'm sure you believe there's a process. That's what everyone believes. And there probably is some very inefficient word of mouth process, and it's remarkable how fragile those records are. Now, you guys are lucky because more or less the rule of law kind of regulates India. I'll give that much credit. In countries where the rule of law is not so applicable, any person, if I'm a person of power, if I ran a state or a province, this happens many a times in South America. I'm close, I spend a lot of time traveling South America, where his family has lived on some land for God knows 500 years or something, and I'm just some unelected leader or elected leader, it doesn't really matter, and I say, too bad, boss, that land is now mine. I need to build some coffee farm, or I need to build a tower. And there's nothing he can do about it. This happened in mass throughout the 20th century in Europe, in Southeast Asia, obviously throughout different conflicts, and you were just moved. Now, if all of that data was hashed and encrypted and put in an immutable, highly secure, and transparent architecture, by definition, immutable means it cannot be changed, then this person who's trying to take this land could still come and kill you, but has other problems, because that means until I get that hash, I can't sell it. And just by that little change in the way that, so it's really abstracted from that fundamental cryptographic idea of a public-private key. You have changed the way you can enforce something as colossal as a land registry. I mean, you can always still exercise force and kill him and all of that, so that's fine, but you can't sell it. And if I can't sell the land because I still don't have the actual asset, the digital asset, it's pretty useless. I can use it as long as I'm alive, but I can't do much with it. And just like that, because of what Ethereum did, entrepreneurs and developers, open source developers, have started to conjure up thousands of use cases. I mean, you wouldn't even believe the use cases. That's just one. There's at least 50 companies working on that I can ring off. The use cases are incredible. I think land registries are going to be huge for the block. I think governments will actually even get into just putting it on the blockchain because it's simpler for them. There's less paperwork, less money wasted. So there's going to be a balance of that. People have always made the argument for any type of financial assets, stocks, bonds, make sense to be on a blockchain. Healthcare records are another one. Like, we just invested in a healthcare company that's trying to put public healthcare records on the blockchain. I think that's interesting. Will have some serious implications. And then, there's a lot of cool things that can go on the blockchain. But not everything. That's the point of the slide. Not everything is meant to go on the blockchain. Some things are. Anything where security is paramount. Okay, so the Ethereum blockchain. Here's what we're here to talk about. This is the three elements of what the Ethereum blockchain is. Simply put, in English, it is a transaction list. This is the almighty Ethereum ledger. You've ever heard that word, ledger? Ledger is a list of events, a list of things that happened, a list of transactions that were documented. That is the transaction list. All of the transactions that would appear in a block comprise the transaction list. Obviously, a block is nothing but a sequence on a longer blockchain. The way that mining works, and the reason that the idea of a chain, why this became a blockchain in the first place, is because in order to validate the validity of a last block, if I was a miner, whether I'm an Ethereum miner or a Bitcoin miner, I would actually observe in my algorithm, because I'm seeing the entire chain unfold, which one has the longest sequence of blocks. And I would contribute my computing power to that one. Why? Because I'm assuming they figured it out. If they're the longest sequence of blocks, most people have burned energy validating those transactions. That is what I will contribute my computing power to. That is the format of mass consensus. And that is where the name, actually, chain, comes from. You have a block header, which is really a group of 15 elements. We'll break that down. And we have an omer list, like omer list. And that is a list of all uncle blocks included. We'll describe what an uncle block is later. But this is really all it is, guys. This is it. This is the block header. You got the transaction list, and you got the omer list. It's not that complicated. But on top of this miraculous little sequence, you are able to build any decentralized application your minds can imagine. So let's talk about uncles. It's actually funny that they ended up calling this uncles. So sometimes valid block solutions don't make chain. What that means is exactly what I just said. Sometimes even correct solutions to the algorithm that my computer is supposed to solve doesn't end up on the chain. Any broadcast block up to 6 previous blocks back with a valid proof of work, POW. Anytime you see POW stands for proof of work. Proof of work is the consensus algorithm which Bitcoin and Ethereum still use. Proof of work. And difficulty can be included as an uncle. Maximum of 2 can be included per block. Uncle block transactions are not included, just header. What that means is if the transaction for some reason was left off this block for various amounts because the solution, even though it was correct, was still chosen by the next network that it was not meant to be carried forth, the uncle block, which is the header piece of that last block, would still be added into this block, but the entire transaction list would not. It is a way of still showing some type of lineage without carrying all that data that you really don't want. Aim to decrease centralization and reward work. Uncle headers can be included in main block for one of 32 of the block miner's rewards given to the said miner. Miner of uncle blocks receive % of the main reward according to this formula when UN and BN are uncle and block numbers respectively. What does this mean? If you are mining an uncle block for some reason, you are still entitled to a percentage of the mining reward. By the way, the only reason people mine is to receive a mining reward. Just to be clear, you're contributing your computational energy. In other words, you're directing kinetic energy in the form of electricity to this blockchain to validate whether it's real or not, because you believe you're going to get Bitcoin. Or if it's Ethereum, you think you're going to get Ethereum. And when your computer is validating an uncle block, it is still entitled to a percentage of the full miner's fee, which is what you ideally want. And so that is what this breaks down. So, one of the most beautiful things about Ethereum, just like Bitcoin, is that all blocks are visible. If you go to this website, etherscan.io, and I believe it's the same website if you go to etherscan.com, etherscan.com is like a heartbeat, like a pulse of the Ethereum network. Every single transaction, every block, every hash, every coin that's ever moved is on Etherscan. It's quite beautiful. And if you ever just want to stare at a bunch of numbers being cryptographically hashed, that is where you go. In other words, this is the transparency that we are talking about. And so it's just like Bitcoin. If you go to blockexplorer.com, you'd be able to visualize Bitcoins. Ethereum is etherscan.com. Blocks have different structure than Bitcoin, as we already mentioned, for Ethereum. So, blocks faster than Bitcoin and reward is different. What was one of Vitalik's goals, or not just Vitalik, the whole Ethereum Foundation's goals? Man, Bitcoin is slow. That is one of their problems. There's no way we can build a general purpose compute scripting language, a general purpose programming language. There's no way we can run multiple layers of decentralized applications when it's this slow and this expensive. So we got to speed this up. We got to make this more efficient. We got to organize our blockchain in a way that doesn't require so much energy. And that is what they did. Every 12 seconds, a block, well, every 12 seconds is the difference between a Bitcoin reward and an Ethereum one. And 5 ETH was the main reward for ETH coin, and miners can make a bit more by including uncle blocks, which is, remember, adding the small percentage. Really what you're going after is that 5 ETH. When Ethereum started, 5 ETH was like a couple cents. If you was mining in December of 2017, 5 ETH would have been $5,000, and I think today 5 ETH is like $1,000. So it changes obviously depending on the price, but the price is usually a representation of how many people are fighting over that mining reward at that given time anyway. So, the reason blocks are faster is it uses the ETH hash mining algorithm, which is different than Bitcoin's. It helps mitigate ASIC and GPU advantages and involves smart contract execution. Difficulty is adjusted every blocks, not every 2 weeks. This is an important identifier for the uncle blocks. So one of the things, again, that Ethereum is very hell-bent on is actually mitigating what ended up, I call, the mining wars. So for those of you guys that don't know, this is a really interesting topic to go research. Like, because mining Bitcoin became so profitable, and I mean like stupidly profitable. Like some of my friends that started mining companies in 2016, I mean, it was dumb. It was crazy what type of revenues they would have pulled in. And what ended up happening is that you started creating these application-specific integrated circuits. Whereas companies would manufacture circuits only to mine Bitcoin. Imagine how bananas that is. But that would actually allow whoever had that ASIC would be better positioned to win the next block. So this became mining wars. And this actually, I think, more than anything else in the last 5 years, propagated silicon fabrication. So you had this idea of Moore's law, and you had this idea that typically gaming computers drove silicon fabrication. In other words, the degree to which the gaming industry wanted to push computation is how well these ASIC chips would be made. NVIDIA, if you guys know about that company, is a gigantic player that came out and built these magnificent gaming application circuits. And then Bitcoin came out and it just blew all the demands NVIDIA had for those gaming circuits out of the water. To the point where in 2018-17, so much revenues for NVIDIA was being generated off people like me buying miners to run Bitcoin algorithms. It was insane to hear like the CEO of NVIDIA, to hear the CEO of these different chip manufacturers talk about it. And people would set up factories, like rooms 10 times as big as this. You can go look at it, YouTube it, mining factories, where it's literally just rows and rows and rows and rows of these extraordinarily powerful ASIC machines burning obscene amounts of electricity. Why? Because they're mining Bitcoin. And when Bitcoin was rising at that price point, for those of you guys that don't know, between January of 2017, I made my first investment in Bitcoin. It was $900. So approximately what? Rupee terms, 900 by 800. Where's my math, guys? 900 by 800 is what? 900 by 80? 56, no, what is it? Oh man. Yeah, 900 by 80. That is real, huh? 54,000 rupees when I first bought. And I was late. By the end of that year, it was $20,000. So 20,000 by 80 is? Yeah. 1,60,000? More than that. Yeah? 1,60,000 per coin. No, man, it's more than that. For sure it's more than that. Today it's more than that. Say it again? 60? 16 lakhs. That's what I said. Sorry, 16 lakhs. Correct. That's the number. In 1 year, the price of a single coin went to 16 lakhs. Mining Bitcoin costs approximately $1,000 still. Does that make sense? So that price didn't change that much. It got a little bit more expensive. The equipment got way more expensive because imagine NVIDIA releases some obscure chip and within 2 seconds it's all sold out because there's these mining wars. It's bananas, man. It was unbelievable. And so Ethereum said, man, we can't propagate this war on computers. So we wanted to somehow not allow it so that there's because this became a big fear amongst blockchain developers because the idea is that, holy shit, does this mean that the mining of Bitcoin is now centralized in these small silos, China, Eastern, because it can only happen in cold countries. That was the other thing. You needed latency and bandwidth, and you needed extraordinarily cold temperatures because it gets hot when you're computing at this speed. If you guys ever played games, tough games, you'll know your machine starts to heat up. That's nothing compared to mining a Bitcoin, and then doing that at scale, this room would boil. So now you're not trying to pay for AC because that's just going to ruin your profit margin. So you put it in a naturally cold country and leave the doors open. I kid you not, this is what happened. And so the issue, the Bitcoin Foundation, the Ethereum Foundation, they really didn't want this to become the case because then their whole mission of decentralization didn't end up working. So Ethereum really tried to solve this and foresaw it by trying to mitigate some of the advantages of actually centralizing a lot of this computing power. And so that is baked into the ETH the ETH hash algorithm, but that's an interesting little tidbit that you guys should know about. It involves smart contract execution. This is the main deal, guys. This is it. This right here, this idea, smart contracts, I will explain this theoretically, I will explain this programmatically, we will go into all details about this, but that idea changed everything. That was the manifestation of the general purpose programming language, the scripting language that would end up becoming Solidity. Oh, and I mean, Ethereum, one of the other fascinating things about Ethereum's consensus algorithm was that it adjusted for difficulty every block. I mean, Bitcoins did that much less frequently. Just 2 weeks. I mean, Ethereum really dynamically captured what it meant to continue to deliver decentralization by adjusting that block, the difficulty to mine a block, whereas Bitcoin's response to mining difficulty would be delayed at least 2 weeks. So the key differences. Blocks keep track of balances, not unspent transaction outputs like BTC. In other words, the big thing in Ethereum is this idea of state. How do you ensure state? State is like the current status the application embodies itself in. In other words, Ethereum is very concerned with figuring out what is the balance at a given point. That will become very important in smart contracts, because smart contracts are all about validating the now. Bitcoin is all about validating, as it says, the unspent. Because what was Satoshi Nakamoto's big problem? The double spend problem. Ethereum didn't care too much about the double spend problem. Obviously, it was a big deal for them too. But they said, well, Bitcoin figured that out. We got to figure out a different problem, which is the problem of computational state in a distributed ledger. Merkle-Patricia trees used. They have 3 branches compared to the Merkle trees. I'm sure you guys in some form have learned about what a Merkle tree is, which is a very commonly used, especially in Bitcoin became the standard, the two-branch tree. And then this is now the big thing in the Ethereum. If you start following Ethereum today, like you start reading about the news, you're gonna, for the last 2 years, you've been hearing about this. Ethereum will transition from proof of work to proof of stake. Dun, 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 dun. So what does this mean? This is huge if it actually works. It's colossal. Bitcoin is obviously famous for validating and proving proof of work. Ethereum and some other blockchains believe that proof of work is a waste of energy because you incentivize crazy people to build huge mining factories that just does nothing but burn electricity. Why shall we not redirect that energy and not make it so futile and run the algorithm through something called proof of stake, POS, which is a different type of consensus algorithm, which instead of making me decrypt the hash functions by solving very extraordinarily complex problems, in other words, burning my computational power, requires me to stake or commit or invest, whatever you want to call it, Ethereum. So let's look at the 2 frameworks. Bitcoin is saying, and even Ethereum today is still proof of work. They haven't transitioned because it's not easy. But Bitcoin today and forever until now has said, in order to validate a node, in order to be a Bitcoin miner, you must prove that you solved this math problem. By virtue, we know that you burned electricity. Electricity is not free, so we know that you're invested into this network. Make sense? There's actually a very interesting Misesian economic theory that underpins even that, which is the burning of something scarce to then validate and is to convert scarcity into abundance, which is what he did with bits. I'll go into that later. But it is supposed to happen in the next couple of quarters, next couple of years, when the entire Ethereum blockchain will transition to a proof of stake. The Casper protocol was something along the lines of Constantinople, which also was supposed to be this transitional protocol from proof of work to proof of stake. You can see the appendix for more details. I'll send that out after. Ethereum nodes. What do they do? Remember, anyone can be an Ethereum node, just like anyone can be a Bitcoin node. Validates all transactions and new blocks. Pretty simple. You need a node to do that, or else they're not a very helping part of the node family. Operates in a P2P fashion. Obviously, there's no central party that authorizes the adjoining of a new node. Each contains a copy of the entire blockchain, very similar to Bitcoin. You must run the entire Bitcoin or Ethereum blockchain to run a node. Light clients. Stores only block headers. This is interesting because, again, what Ethereum wanted to propagate is much more data into each of their blocks, because not just transactional data. They're going to hash everything because they want it to be general purpose. And so they said, well, we can't keep every piece of data. That would become stupid. Let's keep the block headers. Provides easy verification through the tree data structure. So if you guys understand Merkle tree and you'd be able to understand the Patricia tree, you'd understand that even without storing every bit of data in the blockchain itself, using the block headers and reversing the tree, you are able to validate you're able to dehash whatever data that you are trying to validate. Doesn't execute transactions, usually used primarily for balance validation, and is implemented in a variety of languages: Go, Rust, Solidity, etc. Rust became Solidity, etc. So let's talk about the components of Ethereum. Accounts. This is very important. There are two types of accounts. There are external owned accounts, EOA. This is the most common account you'll see on Ethereum. And then there are contracts accounts. So let's break it down. If I have an Ethereum wallet, that means I have an EOA. If you ever start an Ethereum wallet, go log into Ethereum wallet, MetaMask, My Ether wallet. Our company has tons of Ethereum wallets that we've released. They live in the Chrome browser, they live in your phone, they live in your desktop. I mean, umpteen amounts of way to interact with the blockchain. That means you have an EOA. A contract account, on the other hand, is used for the use of smart contracts. In other words, I have an EOA, she has an EOA. I mean, see, she has some Ether, I have some Ether. If we were going to now write a smart contract to perform some transaction, we would be able to script a contract account. And in this contract account, we can allocate Ether or whatever the parameters of the script that we wrote. This contract account is like another Ethereum address that's not owned by either of us, but uses something called multi-signatures, which is a format of signing off on these digital signatures that allows both of us to regulate, not even both of us manually, both of us because of the smart contract that we've written, to regulate how that contract account interacts with the transaction. It is a super interesting idea that Ethereum propagated. Wallets, a set of one or more external accounts. You can have many external accounts in a wallet, and it's used to store and transfer Ether, just like any Bitcoin wallet. So, external accounts, EOA, valid Ethereum address, as associated nonce, amount of transactions sent from the account, and the balance. So, if I pulled up a external account, I would know the balance, like I have 1 Ether, and all the transactions. This is what you would see if you had any Ethereum wallet. Code hash. The hash of the associated code, i.e. a computer program for the smart contract, hash of the empty string for external accounts, EOAs. This is, if you were to actually look at this external account in an Ether scan or look at it on the native Ethereum blockchain, run a get server or whatever it is, you'd actually be able to see all the smart contracts that this account had initiated. Because in order to run a smart contract, you also need first an external account with Ether in it. You'll understand why you need that after, but you do need it. And the storage root is a root hash of the Merkle Patricia tree of the associated account data. So that will also be associated with every external account. Now, if you have a normal cryptocurrency wallet, you won't see all of this. You'll only see the first part. I mean, you won't see any of these 3 pieces of data. You'll see what I was on the previous slide. This is if you're interacting with the Ethereum blockchain itself, you would be able to unpack this. But don't be fooled. Every single Ethereum address has one of these, as long as it's a real Ethereum address. So I can actually show you what some of that looks like after. So, contract account. Ethereum accounts can store and execute code. This is, like I said, the big innovation. This is what I'm going to spend some time talking about. Because if you can understand this, I think really what Ethereum has done, not to overstate it, it's actually impossible for me to overstate it. I could spend like 20 hours yelling about it. It's impossible for me to overstate it. That's how important it is. It's code that's smart. What I mean by that, even though that sounds like a really remedial statement, if you think about how transactional architecture was formatted until now, hitherto, it would be like, okay, how the idea of automation has even been pushed forward with the idea of smart contracts. So let me explain how smart contracts can be now used. I want to sign an agreement with her. My objective is that for every email she sends me to this inbox, I must pay her some amount of money. That is the transaction architecture. Without the idea of Ethereum, how would we regulate that? As a developer, how would you build an application that invokes the trust in me that she's sending the emails, in fact, and invokes the trust in her that she's going to get the agreed upon monetary compensation? The answer is you cannot. Even if you're familiar with automation tools like Zapier, obviously very new Python scripts. I mean, there's so many things that you can look at. They cannot validate the transfer of funds because unless you are using a blockchain, and more importantly, an open blockchain, you are not in access of the funds in question. So, what was a smart contract? It's basically saying that we are going to both agree on the transaction architecture, write it out in a set of code. We are going to then take that code, that bit of code, that bit is very simple. If she sends to this inbox, then 5 Ethereum is transferred to her wallet. But think about all of the components that are necessary to make that a reality. She needs a wallet, Ether wallet. I need an Ether wallet. That email address needs to be verifiable on the blockchain. Those 3 things exist. You can now write the smart contract. You write the smart contract and you compile it in what is known as the Ethereum virtual machine. You may have heard about this. If you haven't heard about this, I'm sure we talk about it in this presentation. EVM, Ethereum virtual machine. I'm sure you guys know VMware, virtual machines. It's a very common topic in computing. The Ethereum virtual machine is using the same consensus algorithm concepts as Bitcoin. But instead of validating just transactions, it validates that code that we just compiled. And that's where the general purpose programming language is able to execute itself on a distributed network. In other words, you can write any line of code, any code set you want, and have it immutably executed on the Ethereum virtual machine by all of the Ethereum miners all over the world using the same consensus algorithm that it uses for everything else. Now, you've unlocked the power of Ethereum to do anything. And that is what is, like, this contract account becomes so important. That is what smart contracts are. So, Ethereum's accounts can store and execute code. That's what I just explained. Has an associated nonce and balance, because obviously in order for us to engage in this contract, we need balances. Code hash, a hash of the associated account code. Storage root contains Merkle tree of the associated storage data. So you have your externally owned account, which is typically associated with the wallet, has the Ether balance, initiates the contract account. And then you have the contract account, which has all the code that's written and is going to be compiled and run on the mainnet of Ethereum to be validated forever. And the only thing you need to do that is have Ethereum in your main account. In other words, this is distributed computing, not just distributed money. Distributed computing, when you say an Ethereum application is unstoppable, immutable, for good or bad, for better or for worse, nobody can stop it once you put it on the Ethereum network. Example. Private key, this. Ethereum private keys are 66 character strings with OX appended. Always start with OX. If it doesn't start with OX, it's not Ethereum. Case is irrelevant. Same derivation through the ECDSA as Bitcoin. This is an example of an Ethereum address. This is an example of an Ethereum private key. Ethereum private keys map addresses directly, simply the last 40 characters of the KEKAK 256 hash of the public key. Address is 42 characters total, appended with 0x in the front. Very simple stuff. All the private keys do the mapping for the Ethereum addresses. The private keys are always 66 strings starting with OX. The wallets themselves, the addresses are 40 characters starting with OX. Transactions. A request to modify the state of the blockchain can run code, contracts which change the global state. Contracts contrasts only balance updates in Bitcoins. This again shows you the transactional nature of Ethereum. Every transaction you put on the Ethereum blockchain is a request to modify the state of the previous block. You are updating the balance. You are updating the result of the previously compiled code on the EVM, on the Ethereum virtual machine. It can run code, it can run contracts. It is signed by the originating account. If I'm the one executing the transaction, if I'm the one proposing the smart contract, my public key signs off on that contract, on my EOA, from my EOA. Type, send value from one account to another, create smart contracts, execute smart contracts. These are the three things you can do in an Ethereum transaction. Obviously, within these three things are an umpteen amount of possibilities, millions to be exact. Ether denominations. This is kind of where people get confused. I'm going to try to explain this as simply as possible, but it's not, don't get gung-ho on this because it's not going to kill you if you don't understand. So there's a couple different names for Ether. Like if you think about like Hindu gods have all of these like manifestations, that would be like a good way to think about Ethereum because people seem to call it in different denominations based on what format of Ethereum we're talking about, but it's always Ethereum. So Wei is the lowest denomination of Ether, meaning the smallest form. A Bitcoin is a Bitcoin, and then a Satoshi is the smallest integer, so the smallest amount that a Bitcoin can break down into. Same thing with Wei. It's named after Wei Dai, the author of B-Money paper. It's a good paper that you should read if you have time, 1998. Many core concepts used in Bitcoin. That is a Wei. So it's very small. Szabo is the next denomination named after Nick Szabo, who was a very prominent cryptographer whose philosophies influence Bitcoin, Ethereum, and so many other things. And that becomes the second smallest denomination, as you can see. And then Finney is the second highest denomination after Hal Finney, and then received its first transaction from Satoshi Nakamoto. And then the cryptocurrency that you all know is Ether, which is actually a very large denomination of Wei. However you want to look at it, you can either say Ether is the largest denomination of Wei or Wei is the smallest denomination of Ether. But these are the different ways that people, and especially when you're talking in the micro-transactional world of Ethereum smart contracts and you're looking at different transactional architectures, Wei is actually what you speak in. A lot of the fees that are required to run your smart contracts on the EVM are paid for in Wei, because if you had to pay for them in Ether, no one would be able to afford to run any of these transactions. So Wei is the way that you want to actually pay for your fees because it keeps things quite cheap. Smart contracts, executable code, Turing complete. Does everyone in here understand what that means, Turing complete? No? Okay, you should really go learn what that means, Turing complete, because that is the fundamental philosophy of any of these general purpose applications, these operating systems. The way that Ethereum was constructed was to be Turing complete. In other words, if you look at your phone, that is any Android phone is a Turing complete device. It is unlimited in the amount of things you can do on that Android phone. You can program it to do virtually anything. That is the same programmability, programmable money is what Vitalik called it in his white paper, and that is what it means to be Turing complete, named after, obviously, very famous mathematician Alan Turing. So, it functions like an external account. Like I said, just like an external account, it functions a contract account. It holds funds. It can hold funds on behalf of two people that haven't agreed on something yet, or have agreed on something. It can interact with other accounts and smart contracts, and it can contain code. And it can be called through transactions. I mean, this is really interesting. You can set up unlimited amount of contracts accounts to manage your smart contracts. These contract accounts could hold unlimited amounts of money. Trust me, today, there's a currency called MakerDAO. Maker, M-A-K-E-R-D-A-I, named after like this DAI. And it is a smart contract built completely off Ethereum, which holds in the smart contract 5% of all Ethereum. So put that in perspective, that is some, I don't know, today's market cap, $20 million, $30 million. And that was just written on top of Ethereum. There's a really interesting use case for MakerDAO. It provides a stable coin for Ethereum. But that's how big these things can come. You're talking about holding hundreds of millions of dollars in a couple lines of code that's just run on top of the Ethereum virtual machine. The way that these propagate is utterly remarkable. Code execution. So this is what I was talking about earlier. The Ethereum virtual machine becomes the execution platform for all smart contracts, all transactions, everything that is needed to happen to update the balances and/or states on the Ethereum network. Every node contains a VM similar to Java, called the Ethereum virtual machine, compiles code from a high-level language to bytecode. It is de-abstracting what is written by you guys. It is taking whatever programming language, like we said, Go, Rust, now Solidity, and bringing it to the machine, the Ethereum level. Now, used to be a machine sits in a server in your house. It then went from that to sitting in Amazon storage. That's what Amazon Web Services is. Amazon Web Service, Google Web Service, whatever it is. Now it's sitting on all of your computers. There are even platforms today, Sia Coin, some of these really interesting decentralized computing platforms, think about this, that allow all of you to dedicate storage to a decentralized cloud so that I, instead of putting my files onto Google Drive, can put it onto this Ethereum drive, and it is decrypted and stored on all of your computers. And you guys would earn money, Ethereum, for allowing a distributed storage network to utilize your excess computational space. Unlimited amounts of unlimited amounts of distributed storage state. Again, maintaining the integrity of the updated state in a Ethereum transaction is the most important thing. State becomes the most important thing in Ethereum. Gas. Well, nothing in life is free, and neither is using Ethereum, because you have to pay for it in this thing called gas, which is just Ether. But again, another name, here it comes. Halting problem. So the infinite loop, this is the reason for gas. I mean, the idea is that Alan Turing really propagated this idea that you would enter into this like recursion cycle of where a computational algorithm would just loop and loop and loop and loop and loop and loop. And if you gave it a distributed machine to run on, it would just continue looping until all the resources of that distributed machine are completely suffocated. Meaning, how do you prevent a smart contract that I wrote for her and me to transact on this email transaction, not just to keep running forever and ever and ever and waste all the precious computing resources? That is why they created gas. So, cannot tell when a program will run or when it will run infinitely from compiled code. The solution: whenever there's unlimited traffic, you charge a toll. Charge a fee per computational step to limit infinite loops and stop flawed code from executing. In other words, it costs to use the Ethereum network. It is not free because you have to pay the miners. You have to keep this network incentivized. In order to keep it secure, you must make sure that everyone is on the same page. So when I wrote that smart contract that allows me and her to transact without any trust, me and her need to have a tiny bit of gas, Ethereum, to actually allow this transaction. And every time we use it, we're not using it manually. Every time it actually runs a smart contract, it is burning gas. It is costing us money. That is what gas is. Every transaction needs to specify an estimate of the amount of gas it will spend. For example, if me and her feel that we need this transaction validated immediately, then we would say that we're willing to pay more gas. You could write that into the Solidity contract. If we didn't care, we're willing to wait a couple hours, days, then we would not specify and we would have a lower gas fee. When we built our first decentralized wallet at Nvest, we made a cool little interface that actually allowed you to create talk with the chat bot where you set your gas fee by shooting the shit with them. Like you tell him you're in a rush and he would tell you what the gas fee should be. And you tell him what you're trying to do with the money and he would tell you what the gas fee should be. And that's really a good way to think about it, is that a gas fee you are getting to propose and bid, hey, Ethereum virtual machine, do my transaction first, I'm in a rush. And that's how the gas would regulate it. It essentially measures how much one is willing to spend in a transaction. Even if it's buggy, this is the crazy thing. Even if the code is completely faulty, I've seen this so many times on the Ethereum network. Even if the code is faulty, it will execute it. It's going to cost money, it's going to be inefficient, but it will execute it. Again, that is the power of the immutable code of the Ethereum network. Gas cost. So, the current market price of a unit of gas in Wei, you can always find live at ethgasstation.info, which I always thought was a really cool name, is set before any transaction by the user. The maximum amount of gas the user is willing to spend helps regulate the load, and the gas cost when used when sending transaction is calculated by the gas limit multiplied by the gas price. All blocks have a gas limit, maximum gas each block can use. So if we set our gas limit to 1, as soon as we run out of 1, transaction shuts down. Proof of I spent some time talking about this, so I'm not going to spend too much time. POW versus POS. Ethereum is in the process of moving to POS. This approach does not require large expenditures on computing and energy, i.e. you don't need to spend thousands, if not millions of dollars buying application-specific circuits. Miners are now validators and post a deposit into an escrow account. And the more escrow you post, the higher the probability you will be chosen to nominate the network. In other words, if we're all putting in Ether into the mining smart contract, and one of you put in 10 times as much as everyone else, the likelihood of that person, that node, that Ethereum address getting chosen to validate the latest block and thus receiving the mining reward is 10 times as much as everyone else. So you can increase your chances by staking more Ethereum. Why does that work in a game theoretical fashion? If I'm the person with the most money invested, I'm probably going to make the right decision to support this network. And that is the same proof of stake concept that Ethereum wants to take to the next level. If you nominate a block with invalid transactions, you lose your escrow. They will take all of your money. I'm joking, they don't take it. It just gets depleted and sent back into the Ethereum network. That is a very good incentive mechanism to make sure people choose the right transaction and only validate sovereign transactions. Ethereum is in the, so one issue with this approach is that those who have the most Ethereum will be able to get even more. So the rich get richer. That's the common issue with these type of consensus algorithms. This leads to centralization eventually. On the other hand, it reduces the chance of the 51% attack and allows for a near instant transaction approval. This protocol is called Casper, and this will be a hard fork. There's two important words in there. Number one, centralization. So in theory, what you should be asking is, wait, that means if someone who has a lot of Ether comes to this network, they're always going to get a higher chance of getting chosen. That is true. However, it's actually still less centralized than the way Bitcoin is done. Because the way that a Bitcoin miner, in terms of proof of work, achieves advantage is through economies of scale. So let's just do simple, like quadratic math. I have one powerful computer, you have one powerful computer. We have an equal chance of getting the next block reward. I have two computers, you still have one. Theoretically, I should have double the chance that she has, but I don't. I have more than double. Because the way that computation stacks up in a proof of work is that the more you have, it exponentially increases the amount of chances I have to beat her. That's why it's so valuable to have 100 computers as opposed to one. And it's almost useless to have one. Whereas in proof of stake, if I have $2 to her $1, yes, I have more of a chance, but I only have double the amount. So I never benefit off economies of scale from an exponential component. I only get it linearly. So that is as fair as they can get it. It definitely reduces the amount of a chance of a 51% attack. So a 51% attack in Bitcoin is something that was, one of the most important concepts in the Bitcoin white paper, is that no entity shall be able to acquire more than 50% of all mining capacity because then they can reverse the block that they just mined. That is the issue. And so Ethereum believes that it's virtually impossible, once you move to proof of stake, to have this issue. The same issue that would come about in Bitcoin. Now, in order to have 51% of the Bitcoin network today, you would have to take all of Google's computers and multiply it by like 300-400. So it's very difficult. Like, it's very expensive. It's huge. The Bitcoin blockchain is so colossal at this point that that's almost impossible. Where the Ethereum blockchain is smaller, still very large, they believe that transitioning to a proof of stake will prevent this. And they've baked in different programmatic rules to prevent it. And this is called Casper. Casper is the name of their new hard fork, or one of their forks that is supposed to implement proof of stake. Some other approaches to consensus, so proof of work, which is Bitcoin and Ethereum, proof of stake is Ethereum in the future. Proof of importance is used in NEM. You can go look at the cryptocurrency NEM and how proof of importance is used as in to regulate its consensus. Practical Byzantine fault tolerance, Hyperledger Fabric. So if you guys know what this is, Hyperledger Fabric is based actually on Ethereum. It's worked on with the Ethereum Foundation and IBM. So Linux, IBM, and Ethereum got together and built this idea called the Hyperledger Fabric, which is a fork of Ethereum that allows you to create private blockchains. And a private blockchain is one that could be used by a controlled set of people. So the main difference between a public blockchain and a private blockchain is if I set up a public blockchain, anyone can join it. Even if I'm the person that created it, I can't control who joins it. In other words, it's open source. Once you put something out there that's open source, you can't really control it. Whereas a private blockchain is controlled and permissioned. So I can create a blockchain. Let's say I create one for all the pharmaceutical companies in India, and I can have validators, centralized validators that validate who gets to join, who gets to participate in the node validation, and who gets to be a part of my consortium. So guess who loves private blockchains? Big companies and governments think private blockchains are the greatest thing in the history of the world. If you want to work in IBM, like Consensus, any big technology company, trust me, just learn Hyperledger. You'll have a job walking out of here. It is that coveted because every enterprise, JP Morgan, obviously one of the largest banks in the world, released its own cryptocurrency called JP Morgan Coin on top of a Hyperledger fabric that they created called Quorum. Corda is another one that the banks use. Healthcare companies are coming out with their own. All big companies, big governments love private blockchains. Why? It's permissioned, it's controlled, it's not anonymous. So, but they use actually practical Byzantine fault tolerance. It's a rather interesting way to achieve consensus, but it has its permissioned factors. Federated Byzantine fault tolerance is used by Ripple and Stellar. Ripple and Stellar obviously are cryptocurrencies that took a priority of speed. All Ripple and Stellar cared about is speed, speed, speed. If I send money, I should get it as fast as Google Pay. It should be the fastest transaction on the planet Earth. And in order to do that, you actually did need to solve the Byzantine problem. And in order for them to solve it, they created FBFT, which I cannot explain right now, but you can go into great detail. What underpins Ripple is now being used by Western Union, by a lot of big banks, to actually create this kind of new age SWIFT network that would allow you to create lightning fast transactions. And POET, proof of elapsed time, which is Hyperledger Sawtooth. There's a couple more that are not on here. There is Neo or EOS, I think, which has the biggest one, which is some form of a proof of stake, but they have these super validator nodes which act as kind of like super regulators on top of the EOS network. So there are many variations in architecture designs to constructing a blockchain. Obviously, proof of work is still king. Proof of stake seems to be the more reasonable ones. The top two are the decentralized ones. Then it gets ever more centralized as we come down. So this is what's in a header. Remember we talked about what's in an Ethereum blockchain header. The hash of the included omers stored in the block header. The state root is the hash of the Merkle tree that holds all account information, and then a similar storage structure for all transaction and receipts. As you can see, you have the state root, you have the transaction root, and then you have the receipt roots. You have all of the other things that are relevant to this transaction, such as the gas limit, the gas use, all of the data that's hashed in the header of every Ethereum block. This data is what allows the miner to validate what was in the previous block to be the correct data, and that allows them to continue to propagate this chain if they want to continue to do that. So, Ethereum blockchain state. You have the state root, the transaction root, and the receipts root. This is super important. So, stored in the data structure known as the Merkle-Patricia tree, which is obviously in concert to Bitcoin's Merkle tree, is similar to the Merkle tree used in Bitcoin, but with 3 leaves per node. As you can see, the state root has 3 leaves. In a Bitcoin Merkle tree, you would have 2 leaves. That's obviously the main difference. Tree is cryptographically secured, as any alteration of the leaf or intermediary nodes result in a different root hash. If someone wants to mess around with this data, they're going to mess up the whole hash. If they mess up the whole hash, this miner who's performing this super complex function to get this hash is not going to get it. And when he doesn't get it, he is going to throw this block out the window, figuratively speaking. That is what occurs in order for you to continue validating the validity of this data. And actually, a Merkle-Patricia tree seems to be far more efficient, especially considering the depth of data that Ethereum is able to hash in any single block over Bitcoin. Let's talk about state root. Each node in the state root tree represents an Ethereum address, obviously, from which Ethereum address it came to which one it's going. Each address has 4 components. The nonce, which is the list of number of transactions from the address. The code hash, which is the hash of the associated code. The storage root, which is the Merkle-Patricia tree root of the account storage contents and the balance of the account. In other words, these four elements are within each state root, which are what, and they're written out here, as you can see, the state root is what allows this starts to unravel which pieces of data are crucial for any given validator to validate through their cryptographic hash functions. If you ever wondered what actually validates my transaction, it's proving that all 4 of these things are in conjunction with every other nonce in the Ethereum network. And so that kind of gives you an underlooking at what the state root is. So the Ethereum difficulty bomb, now this is interesting. So the spike increase in mining difficulty, this is like what I talked about, is that it becomes super difficult to mine Ethereum or any cryptocurrency when it becomes expensive, introduced to attempt to reduce the number of miners. Aim to predate shift algorithm from proof of work to proof of stake. In other words, people have spent tens of millions of dollars investing into computers they can only use to mine Ethereum. And Ethereum's about to say, too bad, too sad, you're not going to be able to use them anymore. You should have just bought Ethereum. And to be honest, had they just bought Ethereum, they would have been very happy because Ethereum has done very, very, very well. So in order to do this, they're already building in the incentive structures for miners to go away. And the good thing about cryptocurrency mining is there are thousands of cryptocurrencies to choose from, and if Ethereum is not the ideal one that is relevant to your computer, you can switch to the other one. And to be honest, Ethereum hasn't been the most lucrative one to mine for a long time. There are other cryptocurrencies that are much more lucrative that miners have already shifted their computing power to. Smart contract programming. Let's talk programming. So, Solidity. This is the high-level language that all smart contracts are written in. It is basically JavaScript. If you know JavaScript, it should take you an additional 10 minutes to learn Solidity. I'm exaggerating, but it's almost that simple, right? So if you don't know JavaScript, then you need to really have a firm understanding of JavaScript, but the elements that allow JavaScript to thrive are what Solidity was built off of. And actually at the beginning, more people used this Serpent programming language. A Serpent was based on Python, and some people still wrote fundamentally Ethereum in Go, but at this point, 90% of all smart contracts are written in Solidity. And there are, one of the 10 things that we teach in our certified Ethereum developer course is obviously how to master JavaScript, because once you do that, you can have a firm grasp on the underpinnings of Solidity. There are ways to write Solidity contracts that are efficient, that save you money when you're deploying your smart contracts, and there are ways to write it when they're inefficient. And that a lot of that has to come down to your proficiency in JavaScript. But without a question, Solidity has evolved, and it is universally the language for the EVM at this point. Let's talk Solidity. Is a language similar to JavaScript, which allows you to develop smart contracts and compile the EVM bytecode. It is currently the flagship language of Ethereum and the most popular. Solidity documentation is available on GitHub. Solidity is the flagship at the high level and is used to write smart contracts. And there's a Solidity online real-time compiler. There's a remix compiler available online. You can directly deploy all your Solidity codes in your browser, and you would use something like a WebJS or a Web3 to communicate that with whatever browser you're interfacing with. And that is all you need realistically to run a smart contract. So one of the things that we do on the first day of the Ethereum certified developer course is we teach you how to run like a fundamental hello world type of smart contract and pay for it with gas and actually execute it over the EVM. The real skill, if I was to give you some career advice, because I hire a lot of blockchain developers, like even in our campus I hire a lot, and the skill that separates great blockchain developers from okay ones is communicating, interacting Solidity with your Web3 language. Like figuring out how to deploy and actually interact it on the web becomes the core distinguishing part of a great Solidity programmer, because really with that skill set, you are unstoppable. First of all, you'll never be unemployed, I can assure you of that. But number two, you will become so prolific in your ability to just conjure up any format of computational scarcity and then deploy it without asking anyone. It becomes one of the most empowering things that you'll do. I'm not going to spend too much time talking about Serpent because no one uses it anymore. But if you're a Python fanatic, you'll like Serpent. Atom Ethereum interface is a plugin. I mean, I don't know if you guys use Atom. That's my favorite editor. Like, I think everything else sucks, but like Atom is really good. Plugin for the Atom editor that allows syntax highlighting, compilation and runtime environment. And then the Solidity linter, is a plugin for the Atom developer that allows you to do Solidity linting, which really actually simplifies this. It's already a simple programming language, Solidity is, but Atom makes it even more easy to use. Vim Solidity is a plug for the Vim Vim editor, providing syntax highlighting, and then Vim Syncastic is a plugin for the Vim editor providing compile checking. So this is what a standard Solidity contract looks like. Solidity contract looks like. You will have in any given Solidity contract, you will have a certain amount of parameters that you are required to fill out. Most of these parameters are what is in the nonce that we described, what will be decrypted by any given hash. This one is super simple. And this one will give you whatever the unit value is. You have your function set pint value, and then you'll have your call function, whatever you're looking to accomplish. Now this can evolve into something super complex. I'd be willing to share with Nishan some of the more complex open source Solidity codes that we've written, and they are long. But it really starts off simple, because one of the things I hope you got out of this is the logical element of Solidity. It is super logical. It has a lot of parameters that make it hard to complexify, but the amount of parameters that you could put into a contract is enormous. So let's look at the development workflow. So you would create an account. This is how you create a Solidity contract. You create an account because you need an Ethereum account. You can do that by going to MetaMask or MyEther wallet or any of the open source wallets. You would fund that account. If you don't have real Ether, you can fund it with testnet Ether. Testnet Ether is like fake Ethereum for the purpose of testing your DApp. You would then develop whatever Solidity contract that you're trying to run, whatever your logic is, whatever you're trying to accomplish, you would write out in the Solidity programming language. You can onboard additional users, you can create new accounts. These are all things you can do at the point of development. You would compile it in something like a remix compiler or whatever you're using at the time for your online compiling. You would sign it with the public key of the account that you created, and then you would test it on the testnet and let the Ethereum network validate it on the next block. If that seems to work for you, then you can bring it back and continue to develop it. And at any given point, you can switch from testnet. This is one of the great things about Ethereum. You can switch from testnet, where you're obviously using fake Ether, not costing you any money, and it's not actually being deployed on the Ethereum mainnet, to running it on the mainnet. But that's a really simple and actually very streamlined workflow for developers. So, programmatically talking, we're talking Go, Python, C++, JavaScript, Haskell. Haskell's not used much anymore, but Haskell ended up being very important in another cryptocurrency called Cardano, which actually I was reading today is taking off. Tools, myetherwallet.com, MetaMask, Test RPC. Those are the three big ones. MyEtherWallet and MetaMask dominate the open source Ethereum wallet space. So you have this idea of a faucet in an Ethereum wallet which allow you to get test Ethereum. You can get unlimited test Ethereum, and with this test Ethereum, now you have the ability to run and deploy your test smart contracts. If you want, you can get it from your friends, they say. So you can also get real Ethereum from your friends if they're willing to depart with it for the purpose of your test. Or you can get it from exchanges if you want to buy it. So Ethereum application components. Base application can be developed in any language. Developed smart contract has to be developed in Solidity or one of the other contract compatible languages. And then the connector library facilitates communication between base application and the smart contract. So this is whatever app you've created in your local server, whatever language you run that in, it doesn't matter. Your smart contract is what communicates with your local application and the Ethereum network. This obviously has to be done in a smart contract compatible language. Your connector library is what allows you to communicate between smart contracts and the base app. And this, you are using MetaMask, for example, to validate the wallets that you're going to create and the contract addresses that you're going to create. So sign and deploy. You have bytecodes. You write your bytecodes. That's fantastic. You now have your transaction ready. So your bytecodes are turned into your transaction. Your transaction is then signed in your external wallet, the one that you had to create in order to deploy your Ethereum contract. Now you have a signed transaction, signed with the public key of your wallet. You can deploy it. You can connect in an element of your base application here, and then of course it becomes a live smart contract on the Ethereum network. Like I said, it's a fairly straightforward process when it comes to deploying this. Test RPC chain, local development or test blockchain. You can always check it out here, Ethereum.js/test RPC. So, Ethereum Test RPC, that's the GitHub link, is suited for development and testing. It's a complete blockchain in memory that runs on your development machine. It processes transactions instantly instead of waiting for the default block time, so you can test that your code works. In other words, when you're running something on the real Ethereum blockchain, you have to wait until the next miner validates your block, which depends on how much gas you've allocated, could take some time. With the test RPC, you don't have to wait. You kind of know if your code works or not. Remember, if your code doesn't work, this is going to be very costly and painful. So you'd want to know if it works now. If it processes your I said that already, and it tells you immediately if your smart contracts are running into different errors. It also makes great client for automated testing, because you can run some automation scripts and make sure that any addition that you're making to this code is also compliant. Truffle knows how to use its special features to speed up test runtime by almost 90%. Truffle framework is the most popular framework used for Ethereum development. Oh, and that is the end. Let us see how much time we have left. 3:43, wow, that was great timing. So that is the end of the formal presentation. Is Rafi back? Rafi is not back? Okay. So I think we still have like an hour left, or however that may go. I can open it up some questions if you guys have immediate questions. If not, what we could do is like break, and I know there's no internet, so that kind of limits us in terms of what we can do. I thought this would go for longer, but I'll open it up to some questions. If I'm able to answer them, I will answer them in as much depth as I can. If not, we can have private conversations about them after. And then I guess we have some certificates for you guys, and that calls it about a day. So, any questions? That was a lot of information, so I appreciate you guys listening. Give yourselves a round of applause for sitting through all of that intense amount of information. Oh, back. Questions. It could be questions about anything. It could be questions about this presentation, about anything I said, crypto, Ethereum, Solidity, myself, these lovely gentlemen with cameras, why they have cameras. Unlimited amounts of questions to ask, is there not? If you guys don't ask me questions, I'm going to ask you questions, and that could get real awkward. Go ahead.
My first question, what inspired you to start your company?
Oh, that's an interesting question. Okay, where do we start? First of all, I answered that question the question is what inspired me to start my company. Okay, I answered that question in detail on my YouTube channels, but I will make sure that it's answered here as well. When I was going to school, I went to school for engineering just like you guys, but I went for a much less noble cause of engineering, which is mechanical, which shows you guys like how smart I was for choosing mechanical. The idea that really caught my attention, like I was more or less very entrepreneurial even in college, like even in university, but the idea that really fascinated me about starting this company, like Nvest, was the intersection. Like I used to trade a lot of derivatives. Like for those of you guys that don't know what derivatives is, they're basically a form of futures and options contracts that you can write over financial assets. So they're a very speculative form of investing. So I used to trade a lot of derivatives. So I would be connected to this like group of traders that were really good. Anyway, one day they came to me in 2017 and said, you have to check out Bitcoin. And I said, I already knew what it was. Like same way that you guys said, like I know what it is, right? And one of the traders was much more adamant. He's like, no, Shorupan, like you really gotta go check it out. And so I have a very obsessive personality. And so I trapped myself in a room for like 4 days and I just ripped apart everything I can find on Bitcoin. And I think I came out of that room a couple days later and said, I never want to do anything that doesn't involve cryptocurrencies again, because the intersection of computer science and finance is such a tremendous secular trend that you cannot afford to miss it. And being anywhere near it will mean that you are so much more advanced than everyone else. So I was motivated by the sheer excitement in what I was uncovering as it pertains to cryptocurrencies and the blockchain. The way that I describe it to my employees and so it kind of works as a quid pro quo. Ethereum by far over any of the other blockchains have the biggest developer community. Like it's not even close. I think it's like 4 or 5x, you know what I mean? So because of that gigantic developer community, that inspires a lot of small miners to get involved, right? And then the large miners who already invested, like once you make an investment, you kind of have to stick with it. You can't be wrong. So they stick with it. But a lot of the algorithmic miners, like when I stopped mining, which was like the beginning of 2018, when my company stopped mining, there was the invention of algo mining, which was like a mining algorithm that people wrote to switch between blockchains to optimize their mining rewards, which is like a very advanced automation script that would really make any given blockchain's competitive advantage nullified if everyone used that. The reality is not everyone does use that. There's still, a lot of them are still hyper-specific Bitcoin miners, Ethereum miners. So that's, I think, kind of a legacy standard, plus the fact that it has the largest developer community keeps the Ethereum mining network going. But I mean, once it goes to proof of stake, all of that will be nullified and like Monero and Zcash and some of these other coins have mined really, really well. Like the returns have been really good. Yeah.
So how are they going to do it? Because it's not a small change.
No, it's a massive change. Well, that's the big question. Like, there's no clear-cut answer. And like, to be honest, Vitalik said that they were going to do it in 2018. So like the most important, powerful people in Ethereum thought it would be done by now, and it's not done. And what that implies is it's not easy to do it. And what that also shows you is how incredibly decentralized the governance protocol of Ethereum actually is, because trust me, if it was Vitalik's way, it would already be proof of stake. He wanted to do proof of stake years ago. But it's because the network and the miners and that's another thing, it's almost like the miners obviously don't want to go proof of stake, right? And so there's this element of resistance within the Ethereum network as well. And there's a lot of Bitcoin fanatics that support Ethereum that believe that proof of work is definitely the only way to go. So it's not easy is the first question, and it's not clear cut. They put out Casper, and Casper is basically the transactional phase, the fork of Ethereum that will eventually be fully proof of stake. It will go into a hybrid form first, where it'll be a combination of POW and POS, and then it will go completely proof of stake. Constantinople was an amendment, like it's almost like an amendment to Casper, which is more recent than this. Even I made this presentation, which is even more in depth about how they're going to do it. And then they put out something called Plasma, which is really advanced stuff on how proof of stake is going to work on the Ethereum protocol. Now, technically speaking, they're going to need to fork Ethereum and convince everyone to come with them. Does that make sense? Do you guys understand the idea of a fork in a blockchain, right? So the real question is, do they have consensus to do this? Now, clearly they don't, or else they would have done it. And Ethereum has already been forked. There's Ethereum Classic, and there's other Ethereums as well. They're just not popular because the main Ethereum has held its ground. Now, keeping the network together is going to become vitally important. So I think it's almost like a democratic process at this point, where the Ethereum Foundation has to more or less convince the miners, all the validators, all the developers, in conjunction, that when this hard fork happens, you must come with us, because it is monumentally better than what you're putting forth. And that date does keep changing, because every time Ethereum puts out this new, this is going to be it, people find bugs in it, and of course they're going to find bugs in it. It's a colossal change, right? Like, it's incredible that it's not all bugs. So I would say, if you had asked me to make a bet, that by the end of 2020, Ethereum has probably moved to proof of stake. But if you were to ask me which one of the protocols that they released will carry them into that, it would be hard for me to tell, because you're gonna have to form a lot of consensus, right? It's gonna be tough. But yeah, it's gonna have to be a fork, and they're definitely gonna go to a fork hybrid and then a fork POS fully, because you're gonna have to make use of the miners to some degree. That's a good question too. Oof. Any other questions? Let me ask you guys a question. Why did you guys come to this workshop? What inspired you guys, who really don't, or would not have been exposed much in your formal education, to take up this topic? Say that again. It's very recent. So you like new things? Okay, cool. Any other good answers? Or did you guys just stumble in here and forget to leave? I think I'll probably end it off with this note, and then we'll just consolidate with what Rafi is saying. Like I said, my only goal for today was to motivate you guys to go home and Google everything I said. Because I believe, and many companies, many of your future employers believe, that understanding Ethereum and Ethereum's derivatives, whatever form of Ethereum you want to look into, is going to be so important for any IT professional that it would be you would be qualified illiterate if you don't know what it is, and you would be highly disadvantaged if you don't know how to program on it, considering it's based on JavaScript, and that it would be so simple for you guys to actually learn that additional skill. Then if you want to take it one step further, because some of you are very young, by the time you graduate university, that's another 2 years, 1 year, 3 years, Ethereum and, again, various blockchains will be pervasive in many of the things you guys are using. And if you had asked me in 1999, what would the internet be used for? I would have said emails. That's all that people were using them for. And if you had asked Robert Kahn or Vint Cerf in 1969, what would the internet be used for? They would have said it would be used for an anti-nuclear missile detection, like anti-nuclear communications network, because that was what the internet was actually designed for. And today we are uncovering the verticals of the blockchain, but we are as early as those guys were in the internet. If you look at 2019 and what the internet is used for, it would have blown away those guys. And that is where you guys are at. You guys are 20, 21, 19, 18, however old you guys are, at the cusp of probably the most important technological revolution since the internet. As a computer scientist, this should be enthralling to your very makeup. Thank you so much, guys, for your time. Thank you so much.
I don't know why they been lying, but your shit is not that inspiring. Bank account statement just look like I'm